I would like to welcome our speaker for today's webinar, Parker Zhang. Parker is the Distribution and Marketing Manager for Amphenol Communication Solutions Aurora Business Unit. He brings a decade of industry experience in connectors and semiconductor power devices. Thank you for joining us today, Parker.
Well, thank you, Greta, and thank you everyone, taking time to attend this webinar. And so today I'm gonna, introduce a strategic product of our company, and which called FloatCombo. It's a floating bottle board, and also will be introduce this application in automotive and future trend. And the folding board actually comes from the traditional rigid contact board. It's just adding the floating structure inside the receptacle. You can see my pointing here. So by adding the floating structure, you can have better reliability, and which can survive or apply in the more severe environment, like a vibration environment. And also it will have compared to the traditional board, it will also have another advantage is it can use several pair between two board. For the traditional board, it might be only can use one or two pair between two PCB board. But the floating board, because it's floating feature, it can apply several pair floating board between the two PCB board. As we can see in the market, and we can see some customer use a pair of floating board between the two PCB board. Yeah, it's a big advantage, and I will introduce more detail in later. And also, it's a typical application is one is the automotive, and also the robot arm, and also the commercial LED display. And today I'm going to more focus on the automotive. Yeah. And this our this product family portfolio here, you can see the pitch is 0.5 pitch, and have a lot of mating height, stack height can be changed. You go from the 8 millimeter to the 14 millimeter, and also have a lot of pin contact can be chosen, from the 20 to 140. Yeah. And also this product can support the used car and LV214. Yeah. And here is this feature and advantage. First, as I say, it's a floating board. It has high floating allowance. Can floating in the XYZ direction. This feature can improve the reliability of the connection. And can as I mentioned, it can survive or apply in the more severe environment. And the second feature is the large mating guide. It can absorb some variation when you mating the plug with the receptacle. The first feature is that we have decided enough wiping length for this product. This also can ensure the reliability of the connection. And the fourth is that this connector is actually, it can support high current transmission. You can see here the design have in the individual power pin here, 4 power pin. Each one can support 5 ampere per ampere, and this power pin design, we call the hybrid design. This connector with the single pin and the power pin hybrid, we call hybrid design. And this design is suitable for the application that this high current and also have space constraint, because this design can save the space. Yeah, and so if some more and more application needs more tight space constraint, they can consider this product. Not only can support the high current, also can space this feature. And the five feature is this product also can support the PCIe Gen 4, and so if some application they need have the high data or high speed transmission of requirement, this product will be a good choice for them. And here, this is the typical application in the automotive. For example, I divided them into three session. First is the ADAS autopilot system, and the other is the infotainment system, and the third is the powertrain system. And let me this is the application example. This is a linked system. You can see here there are two boards inside the module. One is the front board, the other is rear board. These four are need to connect together. Our product is used to connect this board together. And actually, sometimes maybe some people will ask why they use this connector here. Why not they just use the bigger board? Don't need to use the two board. So here for the linked system is just the structural limitation. Because they want the linked system more like have the longer shape here at this product. They cannot design the board too big, so they need to use two board to include all the electronic part on the board. So they need two board here. And the second one is the ADAS system. You can hear it's just like the linked system, also have two board. And also I should mention that sometimes they have a main board here, and I have also here not only have one, there are several sub PCB board here. They use the different stacking height. One is for example, one is the stacking height, 13 stacking height, and the other is the 20 stacking height, and also have the 10 stacking height. They have three small board assembled here, because they use the different stacking height board. They can mismatch here, so that will be more saving the space here. And this one is the OBC and DC and DC converter. Also you can see there this is the control board and this is the power board. And actually for this case, this control board and the power board may also some people may ask that why you divided two board, one is the control board, one is power board. Why they put all the electronic part on one bigger board? That's because this power board is high voltage. This is a low voltage, like a 12 voltage. They have power comes from different power supply. So for safety reason, they cannot put it on one board. So they need to use two board to connect in here. And here, I want to more focus on on the train on the EV here. You can see here, in electric vehicle. The first thing, the first train, we lot of the EV maker want to do is to increase the range, right? Because you increase the range, so the user don't need to charge the car very frequently. The car can last longer, can join longer distance, And so actually the first thing they do is to increase the battery capacity, because the battery capacity is larger, the range will be larger. And this will be face a problem is that if you increase the battery capacity, and you normally you will need a longer time to charge the car if you don't change the OBC, right? And if you increase the battery capacity and also want to maintain the charge time or lower the charge time, you need to increase the OBC power. You need to increase the OBC power here. And then if you increase the OBC power, you will need to the transistor, the MOSFET can stand a higher voltage system, high voltage. So this will need to result in a trend that they need to use the silicon carbide MOSFET. And also you can see here that also they have other way to increase the range is to reduce the car weight. And here I will focus on reduce the weight of the OBC and DC-DC converter. This will normally they need to do increase the power density. The power density is that you have the made a power OBC and DC converter lower the weight of the DC and DC converter and OBC, and this will the normal way is to increase the operating frequency of the OBC, and if you increase the operating frequency of the OBC and DC converter, this will lead to more power loss because you see the topology here. They are both and OBC and DC converter. They will have lot of transistor. Here this is the MOSFET, and every time you turn on or turn off the MOSFET, you have a power loss. If you increase the operating system, because you increase the operating frequency, you can reduce the size or weight of the capacitor, inductor, and transformer. So that's why you can reduce the weight. So, but you increase the frequency, you will lead to more power loss. That's also need to result in the use of silicon carbide MOSFET, because the silicon carbide they have lower the power loss, and so why I mentioned this? Silicon carbide applied in the OBC and DC and DC, if you lead to a problem is that because silicon carbide MOSFET turn on and turn off will be very fast, very quickly, and this will lead to a problem. You see the equation here. This is the voltage, and actually this is a reverse voltage, and this is the parasitic inductor of the on the control board here. You can see, and normally we will pay not much attention in this inductor, because it will not cause much problem in the past. But when you apply the silicon carbide MOSFET, the differential time will be very small, because the silicon carbide MOSFET will turn on and turn off very fast. And if this one become very small, and then if you keep the same L, this voltage will be higher, and then this will damage the MOSFET and damage the whole module. And so what I want to mention is that from in the coming trend, because the silicon carbide applied in the OBC and DC converter, we need to smaller this L, smaller the parasitic parameter. because in the past, AL maybe not cause problem. A thin L maybe not cause a big problem, but in the future in the trend, this will be this L need to lower them lower them as much as possible, and and then you can see here also another trend of the EVs. They want to make the EV be a power source, because when you go to a camp or go to a place that far from the city or urban area, you want a power also be a power supply, so you can take the power from the car. You know, so this will need to by directional OBC and DC converter. You know, you can see here that this is obviously topology here. You know, this is the traditional, full bridge topology, and this is the totem pole. You can see here, this one can only support the one direction, from AC to DC, and this one is the AC to DC, and then reversely, you can from here to DC to AC. Also the DC-DC converter is also the same. They are from, it will be you be used bi-directional if you want the EV be a power source, and this will cause the MOSFET or the transistor used in the topology will be double. You can see here, this is only one one MOSFET in here, one we call that active transistor, because active transistor they need the control chip to activate this transistor, and this one totem pole have four, and you can see that there's a single directional. This in the secondary side they're only some diode, because this one only support the one directional from the DC from DC to DC from the left side to the right side, and this one it can support the bi-directional, so you can see the transistor, the MOSFET in the topology will be double. So you can see here, there will be cause two issue. The second issue I mentioned earlier, we need to more strictly control the parasitic parameter of this control board. Actually, this board, you can see my pointer here. So that also it means that we need to control this L, and also the second issue is that the MOSFET will double. You can see this topology, from the trend. If you need to support bi-directional, it will be double. So this cause the problem is that this parasitic parameter controlling will be very challenging in the future. But maybe in nowadays, I think if some EV maker, they want to have have 11K power, or 22 power, it will be cause a challenging. So, and so why I mentioned this? Back to our product, back to our connector. Why I mentioned this? You can see here the use common way to to lower this L. Lower this L is that make the control board as closer to the power board. You can see here is that from the control board we have the NCU and NCU, we call the drive chip here. You have a second node connect with each MOSFET at this power board. So the common way to lower this L is that we lower the circle loop each driver and each MOSFET. So the problem is that if the MOSFET at the power board, will be double will be double in than the past. So for you imagine for the hardware engineer, when you deciding a module here, you will very difficult to balance, make the balance to make every driving chip more closer to each MOSFET because the number of MOSFET are double, and also we need to make this board as closer. It will be very difficult to balance them if you just create one or two channel between these two boards. So back to our product. As I mentioned earlier, one of the advantage of our product is that we can use several board between two PCB boards. So for example, we can if the MOSFET is double, we can use 4 or 6 or 8 pair of floating board between those two boards. So this will be more easier to balance the distance of between every NCU and every MOSFET. So this is the advantage of our of the floating board. So actually, I attend some technology summit, and I have talked to some OBC and DC-DC converter engineer, and that's the way they focus on that this is the challenge they are facing, and they focus on create more channel on between these two boards. I think they don't want to use cable because the normal discrete cable will cause large error. If they use cable, they will use the twisted pair cable or the coaxial the cable. But that's also not the best solution. The best solution they want to use the protocol, create more channel between those two boards here. So and also as I mentioned earlier, we have customer use a pair of floating protocol between two PCB board in the system. This you can see this chain here. You can. I don't know if you know you guys are familiar with this this topology, and but this is the most famous typical topology for the OBC and DC-DC converter. Yeah, and for the hardware engineer that working on that, they want to reduce the distance and create more channel between those two boards, and can reduce the error here. And another one I want to mention is that let me back to I forgot to mention one thing. So sometimes maybe some customer some people ask me why this floating board came out just recently, because the car have over 100 history, but why the floating board work just came out, in the recent years, I can explain to you here is that, the traditional car is actually more like a mechanical machine, just like the engine and gearbox, just like more like a machine. But nowadays, the car, especially the EV, they are more like a smart electronic product, more and more the electronic module implied in the current car, like a ADAS system or the autopilot system, a lot of more and more electronic in the car, and especially some chips, like a NCU or LSP, the chip. This part are kind of very sensitive or susceptible to the environment, especially for example to the car that sensitive to the vibration environment. So if we continue to use the non-floating connection, the ridge connection, it might not be can meet or fulfill the reliability requirement. So that's why this floating portable came out in recent years because the car are more and more more and more the chips or electronic product used in the automotive. And also, I mentioned I forgot to mention also one thing. This ADAS system nowadays they are I attend some technical summit this summer, and actually nowadays this module the signal they need the electronic component here, the connector here, I need to support the PCIe Gen 3. Nowadays is but they're moving but they are right now looking forward to PCI Gen 4. So as I mentioned here, that's why we made this product can meet the PCI Gen 4. If you're familiar with the ADAS systems module, you can see nowadays currently most of the ADAS system are only support the PCI Gen 3, but they are moving forward to the PCI Gen 4 where maybe in the next year or in the coming years we will yeah. So okay, so that's all my presentation today. So I don't know if I do it very well. So maybe you can have a move on to the Q&A session and see if you guys have any question. I can answer you online.
Yeah, thank you, Parker. That was great. And we will now open our Q&A session if you have any questions for Parker at this time. And Parker, I do have a question for you. Can you increase the pin count to over 140 if needed?
Yeah. So nowadays, currently we are only support 20 for 140, actually, your question is that if we can increase over 140. Actually, in terms of the manufacturing, it will be a lot of problem. And we are working on have the 160, but I also can tell you that if you increase the pin count, the challenge of manufacturing will be greater, and the greater manufacturing challenging means high cost. And so, for example, some customers they want the 200 pin count. Sometimes they will, they would rather pay two 100 pin count and combine together. This will be, for them, they have told them they say this will be more cost effective and more for them. So, but anyway, if any customer, they have a significant demand on, 116 or 118 or 200, that's okay for us. We can customize for them. Yeah, that's not the problem. It's just that, if they want to, the demand is not very big, we will otherwise then recommend it then use two small pin count combined together. For example, they want 200, we will can you recommend it then use two 100 combined together. Yeah. Second question.
Great. Thank you, Parker. And we do have another question. Is there additional screws needed to hold the attached PCB, or the connectors are strong enough to be able to avoid additional screws to fix the top board to the bottom one?
Yeah. Nowadays this product we didn't decide the additional screw. Yeah. But this product can we are very confident that this product can meet the reliability requirement. It will be not a problem. I know what what these people concerned, be concerned that maybe you need the school to fix the connector, made a connection more reliable. But this will be no problem. As I mentioned, this series product, we have do a lot of official tests. You can pass the used car and also the LV214. So this will be no problem. But this one, we have not decided school on it. Yeah. Yeah. But if it's, if customer they want to uh design a version with school, if we can actually we can customize for them if they have the large demand, or have large demand on the market, we can decide that. But in terms of the manufacturing or technically, it will not be the problem. Yeah. Okay.
Thank you, Parker. And what is the standard lead time for this product?
Mm, officially, we will promise 45 days. Yeah,
Mm,
45 days. Officially, we will promise 45 days. But normally, we can make it within 1 month. Normally, not a scenario, we can make it within 1 month. Yeah.
thank you. And can you tell us more on how the power pin design can save space?
Oh, yeah. Okay. So, as I mentioned here, this power pin design can save space. Yeah. Um, you know, you can see this power pin can support 5 ampere, and this single pin small pin, because small pin can support 0.5 ampere, which means that the reading current of one power pin is equivalent to 10 single pin, right? Yeah. And you can see the 10 single pin under zero point 0.5 pitch, which will be takes up or consume more space than one power pin. So for the power, if you need to fulfill your current requirement, the independent power pin will be saving more space than the single pin, because for example, I remove this power pin. If you need to if you need to transmit 5 ampere power, you need to take 4 single pin for this current transmission. For example, 100 single pin, and then you use 19 single pin for the signal transmission, and then you need 10 single pin for the power transmit. So that this 10 power pin, this 10 single pin will be consume more space than this single power pin. So this pin actually this pin is the most the most advantage. The biggest advantage is saving space for the for the traditional design. Yeah.
Great, thank you, Parker. And that is all the time that we have left for today. So I just want to say thank you to everyone for joining us today, and we hope you enjoyed today's presentation with Parker Zhang from our Aurora business unit. Have a great rest of your day.